Okay, so in the final question, we're asked to plot a graph of some logarithmic data or natural logarithmic data that we've got from a rates reaction. So you get your first mark for drawing a sensible scale, so 6 up to 15, taking up the entire page. You get your second mark for drawing a sensible scale on your x-axis, which is 1 over t. Okay? So I am going here from 1.4 times 10 to the minus 3 up to 1.8 times 10 to the minus 3, which I have got from that table there. Then I end up with a nice straight line when I draw my graph. So I get a mark for drawing a straight line. I get a mark for calculating my gradient. Okay, so I've done change in y over change in x. And I get a mark for calculating my gradient, which in my case is minus 22,000. There's a range which was acceptable, which was minus 20,000 up to minus 22,000. So I'm just okay here. Okay, and then it tells me in the question that I have to calculate the activation energy to an appropriate number of significant figures. It doesn't tell me how many significant figures that is. Okay, well, my limiting factor really is the number of significant figures that I have in my data. So in some of the data, like 0.015 for example, I have 2 significant figures. Okay, so therefore I might do it to either 2 or 3 significant figures, because there are lots of them. 7.73, 9.71 for example, 0.00159 for example. I have 3 significant figures. Okay, so to work out my activation energy, I just multiply the gradient by r, the gas constant, and take the negative of that answer. Obviously, this gradient is going to be in joules, and I need to convert it into kilojoules. So I need to divide that answer by 1,000, and I end up with, in my case, plus 183. The actual answer is plus 181, so I'm quite close here.